Complete the tables of values below and plot the graphs on the axes below. So the first graph I've got is 2 over x plus 2. Actually, let's just do this in quite a nice way here. I'm going to define a function. I'm going to call it f, variable x, and I'm going to put in here 2 divided by x plus 2. And then that's done. And so when I want the value when x is -4, all I'm going to do is go to here, I'm going to find f, and I'm going to put in -4. And it tells me that it is -1. And then I'm going to do f of -3. And that is -2. And then I'm going to do f of -2.5. And that gives me -4. And then I'm going to do f of -1.5. And that's going to give me 4. I'm going to do f of -1. That's going to give me 2. F of 0 is clearly going to give me 1. F of 2 is going to give me a half. And f of 4 is going to give me 1/3. Let's do the other table. So what I could do here, there's another way of doing this. Let's do it that way. Let's go to graph and table. I'm just going to clear anything I've got there. And I'm going to put in this graph, which is -1 over x minus 3. And rather than graphing it, what I'm going to do is generate a table. And then I am going to start my table at -2. I'm going to end my table at 5, and I'm going to go up in steps of 0.5. And so for -2, I can see that my answer is 0.2. For -1, it's 0.25, which we know is a quarter. At 0, 0.3333, that's going to be 1/3. The next value I want is at 2. That's 1. Then I want 2.5, which is 2. 3.5, which is -2. I want the value at 4, which is -1, and I want it at 5, which is -0.5. Okay, so let's plot this first one in green. So I've got -4, -1. -3, -2, -2.5, -4. -1.5 is 4. -1, 2, 0, 1, 2, 1/2, and at 4 it's 1/3. Now that looks to me very much like the graph is going to go down here. And we know the shapes of these graphs. and it's going to come down here. Now you could check this by graphing it, but it looks very much like the asymptote, the vertical one, is no longer the y-axis, but is actually the line y equals -2. Remember, the green curve here was y equals 2 over x plus 2. Now we've got to plot the other one, and I'll do that in orange. So I've got -2, 0.2, -1, 0.25, 0, 1/3, 2, 1, 2.5, 2, 3.5 is -2. 4 is -1. 5 is -0.5. Well, once again, that looks to me like the asymptote has moved. The asymptote now seems to be y equals 3. We know the shape of the curve, which is how I was able to identify the asymptote. The horizontal asymptote is still the x-axis. And seems to go like this. So this orange one is y equals -1 over x minus 3. What happened to the asymptotes for each curve? Well, if we look at y equals 2 over x plus 2, x equals -2 is now the vertical asymptote. So the vertical asymptote will help us identify the value here. Note the sign is changed. -2 is the value that will make the denominator equal to 0. And you know you're never allowed to divide by 0, which is why we get an asymptote there. Y is -1 over x minus 3 has x equals 3 as its vertical asymptote. And once again, 3 is the value that would make x minus 3 equal to 0. Show that we can still identify a equals 2 and a equals -1 for these two curves. So let's look at the orange curve. This is where the asymptotes cross. If I go 1 unit right, I go 1 unit down, which is -1. This is the point where the asymptotes cross for the green curve. 1 unit right is 2 units up, which corresponds to the 2 here.